I'm an assistant professor at the University of Colorado in Boulder in the Information Science Department. And I will be talking about interpretability in machine learning from the perspective of one of my main research areas, which is topic modeling. So I'll be surveying how interpretability is defined and addressed in topic modeling. And then I think it'll be interesting to think about whether some of these concepts from topic modeling could be applied to other areas of machine learning. So just for a little bit of background, a topic model is a probabilistic model that takes as input a collection of documents, such as news articles, and it outputs a set of what are called topics, which are these groups of hopefully semantically related words. So these examples here are taken from running a topic model on a corpus of Associated Press articles. And you see topics about like crime and politics and so on. So a little bit more formally, a topic model is defined by this probabilistic process where each topic is a distribution over words. So a formal definition of a topic is a probability distribution of words. And the way topics are visualized and presented to people is usually by showing the 10 or 20 most probable words in a topic. And then under this model, each document has a distribution over topics. And then by estimating the parameters of this model to maximize the likelihood or how to best explain these documents, then we can infer what these latent topics look like. And often they result in these clusters of words with high probability that are generally semantically related, and they tend to co-occur together in documents. So why do people use topic models? There are a bunch of ways topics can be used. So just a basic use is they can be used to identify just the major themes in text. So you give it a corpus, it outputs the topics that are most commonly discussed, and so this is sort of a high-level way of characterizing the content of a corpus. And with that, you can ask questions like, what do people talk about on Twitter? What topics are associated with different people or different types of accounts, and so on. So that's one example. And relatedly, people have used topic models for corpus exploration and for creating tools and browsers to navigate a corpus. So these screenshots up here are from this tool by Jonathan Goodwin. This is the first result if you Google topic model browser. And basically this is a tool that was applied to literature. So this is a person who works in digital humanities, and it shows the topics of this corpus of books from the 1920s. And then someone can click on a different topic and then see which books are a good match for those topics. So topic models can be used for browsing text collections. And then another fairly common use of topic models is to look for trends, for example, over time or geography, in the topic content of some collection. So this screenshot up here, for example, is from this study from, this was an NLP paper from a few years ago, or quite a few years ago now, where they took all papers that were published in the major computational linguistics conferences from the past 20 or 30 years. They ran a topic model to extract the different topics that are discussed in these papers, and they plotted them over time, and they found patterns such as, this plot is showing two topics about machine translation, that's what MT stands for here. They showed that classical MT approaches, which tend to be rule-based, sort of peaked pretty early on in the 80s, and have started to drop down, whereas statistical methods have just been going up and up. So this is an example of a way to extract these trends without doing any time-consuming rigorous annotation process, because the topic model just extracts this all automatically, which is why people like them. However, so the reason I use these three examples of uses, although there are other uses of topic models as well, is all of these assume that topics are actually meaningful to people. So if a topic model is to be useful as a browser, people need to actually look at these groups of words and understand what they mean, and it has to make sense to people. This is especially true in something like this, where you need to trust that the topics are actually representative of some concept that people care about. So all of these assume some sort of interpretability from the topic model. Though anyone who's used the topic model, of course, knows that it doesn't always happen that way. Not all topics are nice and clean. And certainly some topics will just look like junk. So for example, here are more topics from the same associated press corpus that I showed you earlier. But if you look at the words, it's not clear exactly what the meaning is or what the connections are between them. So I'll talk a little bit now about how researchers in the topic modeling community address this issue of interpretability, because this is an area of machine learning where interpretability has long been important, because a motivating reason to use topic models is for those human-centered applications that I showed you. So I'll talk a little bit about how people evaluate interpretability in topic models, and a little bit about how to train topic models in a way that makes them interpretable. So there's been a fair amount of research, especially more recently, in how do you evaluate the quality of a topic that is produced by a topic model. And there are different approaches to this, but they all center around this concept of coherence. And the idea is, in this set of, say, the 10 or 20 most probable words in a topic, how interrelated are all of these words? Do they form a coherent concept, or are some of the words not related to other words in a topic? So these are some examples from this paper by Newman et al. Showing topics that humans have judged to be coherent or not coherent, and I think you can see a clear difference. And so, formally, different ways of measuring coherence have been proposed, both using automatic metrics as well as human judgments. So one way to measure the quality of a topic is just to ask people and have them measure it on a Likert scale, but this is pretty subjective, so people have come up with tests to give people that are a little bit more objective. So one that I like is called the word intrusion approach, where you take, say, 5 or so words from one topic, you randomly insert a word from some other topic, and you ask people if they can identify the out-of-place word. So if the original topic is highly coherent, it'll be obvious which word is out of place. If the topic is just noisy and junk, then it'll be hard to tell which word is out of place, because all of the words will look out of place. And so this is a human experiment that can measure the coherence of topics. People also propose other metrics. And there are lots of metrics that have been proposed. There are several papers. I cite just one of them. But all of these metrics are basically measuring the similarity of all pairs of words in a topic. So for every pair of the top 10 or 20 words in a topic, how similar are they? And similarity can be based on metrics like mutual information. This metric is related to conditional probability, and so on. And these metrics have been shown to be correlated with human judgments or word intrusion scores. So this is a faster way of measuring that. So these are currently the most standard ways of evaluating the quality of topics. I'm going to talk less about training than evaluation, but there has been some work on not just evaluating the coherence of a topic model, but also how do you train a topic model that makes it more interpretable. So different things have been proposed. There's some work on having people specify which pairs of words are or are not coherent. So people can specify as a prior that these two words should be in the same topic, or these two words should not be in the same topic, and so on. There's related work on doing a similar idea, but rather than having human feedback, again using automated metrics like what I showed you in the previous slides. So words that tend to co-occur in a corpus, or have some high similarity score under some metric should appear in the same topics. And then finally, as was discussed in the panel this morning, there is interactive approaches to topic modeling, where by having a human in the loop, you can train the topics in a way such that, of course, they are more interpretable to people. So that's a survey of the most common ways that interpretability is addressed in the area of topic modeling. And so what I want to present here is just to get you thinking about how these ideas might be used in other areas of machine learning. So in topic models, coherence is the main definition of what is interpretable. And so I want to think about whether coherence is a desirable property in other machine learning models. So say you're training a classifier or a regression model, do you want those parameters to be coherent? If so, when? So that's something to think about. One example that came up in my own research of where I think coherence might be a useful metric for evaluating a model is I do a lot of research in using social media data to track the spread of disease. So, for instance, we can measure how many people have the flu based on how many people are tweeting that they're sick. And if you just naively plug like a bag of words, feature representation from tweets into, say, a linear regression model, what you get are these words on the right here, which are, these are the words with the highest parameter values in the regression model. And some of these words make sense, like sick and flu. Well, what's concerning is that because the flu tends to happen in the winter, the word Christmas is actually a better predictor of flu than the word flu. So this is unfortunate. What this means is that this model won't perform well in a year where the flu happens, say, in September, which does sometimes happen. And so in situations where you don't have enough years of data to evaluate, say, the F-score of this model, one thing you could consider is the coherence metrics from topic modeling, because the word Christmas is going to have a really low association with the word flu, and so this set of predictors does not form a coherent topic, basically. So something to think about is whether the idea of coherence could make a model like this less susceptible to noise and more robust and so on. So basically the takeaway of my talk is that there is a fairly large body of research on interpretability, specifically within the topic modeling community. And something to think about is how to incorporate this research on interpretability that people have been doing in this community and putting it into a larger machine learning community. So I'll just mention that some work that's now ongoing is testing whether the coherence metrics from topic modeling are in fact useful predictors of accuracy in, say, classifiers or regression models, as well as how to train other models to be coherent. So those are the things I'm thinking about, and that's all I have.